Ray casting is an important feature of a physics library. Ray casting is the method of testing if a straight line of sight exists between 2 points. It works by casting an infinitely thin ray from point A to point B, checking if it intersects with any objects along the path. The function we will implement allows us to pick objects in the scene with the mouse and move them around. Ray casting is useful in many scenarios, such as spawning objects at runtime in collision-free locations, testing joint limits and strengths on complex models, actions like actors that can open doors, windows, grab items, determine line of sight, and more. Let's begin by setting up the scene. In Unreal Engine, a simple test level provides a flyby camera, but it's not available to the player by default. We need to spawn it at runtime. Adding a spectator pawn, which can be toggled on and off with a key press, is a common task in Unreal projects. Many online tutorials can guide you through the process, so feel free to check those out. For this tutorial, we will implement it with an added physics feature for picking rigid bodies. Steps to implement the flyby camera. Add a player to the level. If you don't already have a player in your level, right-click in the content browser and import one. A third-person or first-person player works well. In this tutorial, we'll use the third-person player. Create a spectator pawn blueprint. Open the player blueprint, right-click, and create a new spectator pawn blueprint. Give it a name. Set up a key event. Open the project settings panel and create a new key event. We'll use the letter P to trigger the flyby camera. Edit the player blueprint. Double-click the player blueprint in the content browser to open the event graph editor. Add the flyby camera action. Add a new flyby camera action event. Spawn the spectator pawn. In the pressed pin, add the spawn actor from class node and set the class to the spectator pawn you just created. Set the transform to match the player camera or any other value appropriate for your project. Transfer control to the flyby camera. Add a possess node to transfer control from the player controller to the flyby camera. Compile and test. Compile the blueprint and test it. You should be able to press the P key to switch between the player and the flyby camera. Step 2. Setting up spectator pawn blueprint for grabbing objects. We are now ready to set up the spectator pawn blueprint that will implement the logic for picking up objects from the scene while in flyby mode. Setting up the spectator camera. Open the spectator pawn blueprint and add a Newton World variable. Save the Newton World object. In the Begin Play event, find the Newton World object and store it in the Save It Newton World variable. This object implements the ray casting function. Set up grabbing mode. Add a key event to toggle between grabbing mode and free-flying mode. When in grabbing mode, we will show the mouse cursor. In free-flying mode, we hide the cursor. Implement left mouse button for object grabbing. Add an event for the left mouse button to pick up objects. When pressed, check if the mouse cursor is on and if the Newton World object is in the scene. If both checks pass, proceed with the following steps. Trace a ray to pick an object. Use the camera's eye point and direction to trace a ray toward an object. Call the ray cast function to check for intersections. Check if ray cast was successful. If the ray cast returns true, save the hit object and the distance from the camera. This will allow us to interact with the object later. Create a kinematic joint. Spawn a kinematic joint to link the picked object to a fixed position in the scene. Set the joint parameters as needed. Release object when mouse is released. When the left mouse button is released, reset the grabbing state. If the object is being held, detach it from the kinematic joint and destroy the joint. Move object with mouse. On every frame tick, check if an object has been picked up. If so, convert the mouse's current screen position into a world location. Use the saved hit distance to calculate the new target location for the kinematic joint and move the object accordingly. Step 3. Returning to player mode. Finally, let's make sure we can return to the player mode from the flyby camera. Press P to switch back. When the P key is pressed again, switch the camera back to the player mode. Check for active grabs. If the camera switch happens during an active grab, detach the object and destroy the kinematic joint. Reset the camera and controls. Hide the mouse cursor. Transfer control back to the player and destroy the spectator pawn. Conclusion. After compiling the 2 blueprints without errors, You should be able to fly the camera around the scene, grab rigid body objects, and move them as needed. So, let us try picking few objects. This method of interaction is just one example. Other similar techniques include convex casting for checking distances between objects, checking for objects in a specific region or volume, and more. We have not introduced joints yet, but on a preview, we can try testing the limits of a door. On the next tutorial, we will introduce constraints joints. The documentation as well as the plugin with all the data are in the links below. Until next time, thank you for watching.